Alright, so this is lab 2 lines of charge. Alright, so a little introduction about this lab. So this lab follows a similar premise as the first lab, in which we are just calculating the charge of a tape. However, in this lab, the charge is distributed evenly across the length of the tape rather than just concentrated at one location. So here's the same data that we used in the same lab, as you can see it on the left hand side there. That's just going to be initial conditions. And in this lab, we also make a couple of assumptions. And those assumptions are that, well, first of all, it's not treated like a point charge, but most importantly, the charge is distributed evenly along the length of each U-tape. So there's the same amount of charge across the whole tape, which is just an assumption that we have to make. All right, so basically, what are some of the concepts that this lab, uses or wants us to focus on? Well, the main concepts are polarization, so a neutral object interacting with a charged object, and due to that becoming polarized as a temporary dipole. There's forces. In this lab, we only have the force of the electric force and the force of gravity, so we can ignore all other forces. And obviously, most importantly, the electric fields of distributed charges. And how you find this is basically through an integral. So basically, you just divide the charged object into a series of point charges and sum all of those point charges. And you use the superposition principle to find the sum. So in order to calculate the new charge, since we have to do what's it called, a sum of charges, we wrote a code, and this is just the part one of the code. So as you can see up there, we defined some initial variables, which is the initial charge that we calculated from the last lab, the mass of the tape, gravity, and the K constant. And then the first function is that you can see right there is used to find the electric field. This is literally just the what's it called, the function from the first lab, basically using the distance r and r hat, and you put all these together to find the electric field. And then more importantly is the second function that finds the line charge by creating line segment intervals along the axis. Alright, so here's the second part of the code. So now that we have calculated the line charges, we have to find the electric force, and so that is what this part of the code does. So basically, this is just summing up all the previous line charges to find the total charge of the tape. And then if we want to actually model this, we could use some arrows. So as you can see right there, we create arrows to calculate the net electric force as well as the gravitational force. So the white arrow would be the net electric force, and the yellow arrow would be the force of gravity affecting the tape. And so there we get the result right there of the magnitude of the electric force and the magnitude of the gravitational force. So on the next slide, you'll see how they compare to previous results. All right, so now that we got the results, um, we got on this lab from the code, we got that the line charge model was about 1.227 times 10 to the negative 8 coulombs, and the point charge model was 8.4 10 to the 9 coulombs. So what exactly do these numbers mean? Well, as you can see, the line charge model is obviously greater than the point charge model. But what exactly does this mean, and why is that? Well, we can look at the second question right here. Why do these estimates differ? Which value is more likely to be closer to the real value, and why? And the reason that these estimates differ is because of the shape of the actual modeled electric field. So the line charge more accurately reflects the shape of the line of tape that we used rather than the point charge, which just be one single point. And so if we look at the first question now, what if you had modeled each of your tapes single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a single point charge model to the value you got with your line model. So basically, what if you like modeled each of the tapes as a single point charge like we did on the last lab? So the model would be less accurate and have a smaller charge as the area of concentration is smaller. And this is clearly seen with the point charge model. value, which is way smaller than the line charge model value. So that was my line charge lab. Thank you so much for listening.